Hi, hello, good morning, and welcome today. I'm going to share to you about statistics with a topic mean of discrete random variables in a probability distribution. So let us now go ahead. All right, so for the mean formula for discrete random variable, let me inform you that this is a different formula that we usually know with regards to the mean of the sample and population in statistics, all right? So what we have here for the mean of random variable with a discrete probability distribution, it is denoted by mu, okay, which is equal to x sub 1 times p of x sub 1 plus x sub 2 times the p of x sub 2 plus x sub 3 times the p of x sub 3 all the way to the x sub n times p of x sub n. All right, so we could write this as the summation of x times the p of x. Okay, we have to note that x sub 1, x sub 2, x sub 3, all the way to x sub n are the outcomes, and then the p of x sub 1, p of x sub 2, all the way to p of x sub n are what we call the corresponding probabilities of x. Okay, so also the summation of x times p of x, it means to sum the products. Okay, so let us now have this first example. So find the mean of the number of spots that appear when a die is tossed. Okay, so let me show you the table. We need to create or construct a table of probability distribution. So having two rows here, we have the first row is the outcome denoted by X, and basically the outcomes for tossing a die is from 1 to 6, and then probability on the second row denoted by p of x. So basically if you see the probability of each outcome here from 1 to 6 has the same probability, which is 1 over 6. Okay, so let us now use the formula to get the mean for this discrete random variables. So we have the mu is equal to the summation of x times p of x, and that is just like getting the sum of the weighted mean of this probability distribution. So we have 1 times 1 over 6 plus 2 times 1 over 6 plus 3 times 1 over 6 plus 4 times 1 over 6 plus 5 times 1 over 6 plus 6 times 1 over 6. All right, so if we're going to calculate this one, so you will have 21 over 6, and simplify this improper fractions to mixed numbers. So this will become 3 and 1 half, or simplify more to a decimal form. So this will give you 3.5. So as a rounding rule for the mean, we have to add one decimal place from the corresponding values of x. So since all whole numbers we have for the corresponding values of x, so we have here one decimal place for the mean. All right, so the 3.5 will basically be what we call the theoretical average of this probability distribution. All right, so let us now go to the second example. In a family with two children, find the mean of the number of children who will be girls. So again, with the table, the first row is the number of girls, which are the outcomes denoted by X, and the second row, the probability of the corresponding outcomes denoted by P of X. So of course, we know for the outcomes for the number of girls, so we will have 0 for if no girls will occur, and 1 if one girl will occur, 2 if two girls will occur. And how do we get this probability correspondingly to 0? So let's take a look on this table. So I have here number of girls, so 0, 1, 2, and the outcome, which is denoted by E. So when no girls or 0 girl will occur, so basically we have only one outcome for that. And for number of girl, if one girl will occur, so basically we have two outcome for that. And then for two girls will occur, so we have one outcome for that. And if we're going to add the total outcome, so that is 4. So this will be our denominator. So basically for 0, we will have 1 out of 4. So this 1/4. And then for 1, this is 2 out of 4. And simplify 2 out of 4, 2/4. So that is 1/2. And then for 2, that is 1 out of 4. So we have here 1/4, okay? And then using the formula to get the mean for discrete random variable again, so we have mu is equal to the summation of x times p of x. So again, it's just basically getting the sum of the weighted mean of these probability distributions. So we have 0 times 1/4 plus 1 times 1/2 plus 2 times 1/4 is equal to 1. All right, and go to the next example, the third one. If 3 coins are tossed, find the mean of the number of heads that occur. All right, so again, we have here that's table. The probability distribution looks like this. So we have a first column again, number of heads denoted by x. Second column, probability, p of x. So of course, on the first, row, okay, we have here possible outcomes for the sample space is no heads will occur, 1 heads will occur, 2 heads will occur, 3 heads will occur. And how do we get this probability correspondingly? Again, let us take a look. Okay, so by listing method or by tree diagram, if you know how to do that tree diagram, we can, that will still the same outcome will happen. And I have here listing method, and here take notes, okay, all of the outcomes that will occur, okay, based on the number of heads. Okay, if no heads will occur, so this will be all tails. 3 tails will occur, so TTT, so that is one outcome. And for 1 head, okay, we have TTH, THT, and HTT. So basically, there's 3 outcomes here. And then for 2 heads, the possible outcomes will be HHT, HTH, and THH. So this is again for 2 heads, 3 outcome. And then for 3 heads, we have HHH only. So for 3 heads, we have only 1 outcome. If we're going to get the sum of the outcome or N of E, that will be equal to 8. So this will be our denominator now. To get the probability now, so we have for 0, we are out of 8 possible outcomes. So we have 1/8. And then for 1 head, okay, so out of 3 possible outcomes, so that is 3/8. And then for 2 heads, that is 3/8. And 3 heads, that is 1/8. So this is how we get this probability, okay, for each of the number of heads, okay, or the outcomes that we have. So therefore, using the formula to get the mean, so we have mu is equal to summation of x times p of x, okay, is equal to just getting all the sum of the weighted means of each of these number of heads and its corresponding probability. So you have 0 times 1, 8, plus 1 times 3, 8, plus 2 times 3, 8, plus 3 times 1, 8. So if we're going to calculate this all together, we will have 12/8. Of course, simplify, it will have a mixed number of 1 and 1/2. And in decimal form, we have 1.5. All right. So this is how we just use the mean for discrete random variable formula. Hopefully you have learned lots of this. And thank you for watching this video. Please subscribe and like this video if you have learned so much. Okay, thank you so much and have a great day. God bless you all. Bye bye. See you next time.